So let's create an empty function and get in there. And the first thing I'm going to do is create a little cheat sheet for myself. And this is giving me the float 4 values for sort of the default, and then when we turn it 90 degrees. And we're going to create a series of if-else statements that are going to correspond to each one of these floats. And that way we can, with that integer, we'll be able to decide which of these two values it's going to use in any of these positions. So these if-elses correspond to x1, y1, x2, y2. Our default horizontal is set to 0. That's the integer that it's expecting for that default, and then if it's going vertical, it's going to be 1. So we can set up our condition to read, if image orientation equals 0, then this first condition on each of these nodes will be put as the output. Otherwise, it'll be the other. And now we have our little cheat sheet here, and it's just a question of going down the line and making this happen. So we're either going to have 1, 0, or -1. Right, so the first condition is horizontal, so x1 is 1, y1 is 0, x2 is 0, and y2 is 1. If it's not this first condition, then we only have 2, so it must be the second. That one is 0 for my x1, -1 for my y1, 1 for my x2, and 0 for my y2. So now I'm going to come in here and vector these results together. So we have our first float 2 result and our second float 2 result. And we do it one more time into our float 4, which is what's required here. And we set that as our output node. And now when we come in here, we can switch the orientation of our image. But this is only dealing with the orientation. We still have another variable that we have to put in here, and that's our image 1 adjustment. And we have to figure out a way of getting those two to work together, because if I come into this transform 2D and I look at this transform matrix that has our function on it right now, the second I change the actual size, I adjust it in any way, it clears out that function we just made. And that's because it's getting two conflicting sets of information. We need to figure out a way of taking this adjustment information and merging it with what we're doing with the orientation. And it's actually pretty straightforward. We have this as a float 2, and we need to separate out what's happening with our y and what's happening with our x and what's happening with our y. And to do that, we're going to use a swizzle node, and we're going to swizzle out a float 1 2 times. And the way the swizzle node works is it takes the information from this node here, whether it's a float 4, float 2, doesn't matter. And the float 1 only has an x. That's it. It's just got the 1. But you can assign any of the other values from this node to this node. In this case, we're keeping it as x. In this case, we're going to want to see the y. So in this float 2 value here, it's going to treat this as a separate float 1, and it's going to treat this as a separate float 1 as far as our function is concerned. And now we're just going to replace the ones and negative ones that we see here with these x's, with the x and the y, according to the spot they belong in. So this first one is a whole number, it's not 0. This is x. Y1 is 0, so we can leave that alone. X2 is 0, so we can leave that alone. Y2 is 1, but instead of here, we're going to give it this y value. And then we go down to the second result. So the first one is 0, we leave it alone. The next one is a negative y, because this corresponds to our y1. So what I'm going to do is I'm going to negate this y and send it in there. For our x2, we have a positive 1. For our x2, we have a positive 1, and then for our y2, we have a 0. And we've replaced any place we've seen a 1 here with the respective value coming out of this float 2. And now when we come back into our input parameters, we're going to be able to do both. We can adjust on the horizontal or on the vertical. We can flip it. Now it's still doing it on the actual horizontal, but because we flipped the image, it looks like it's doing it on the Y now. But it's working. And that's what we need to have happen to all our stuff. So this transform node now, except for the fact that we have to change out the specific variables from the different groups, is going to be the same for all 3 images. And all we need to do here now is come in here and change these out. And we'll do our offset. And now these 3 images are going to move according to their respective inputs. At least I hope they are. That is correct. And this one should function on 3. Yep. So we got them hooked up correctly. And now we have to blend them to each other. But we're going to have to do it a little bit differently. These are grayscale maps. And if we blend them as grayscales, we're not going to be able to get them to do what we want them to do. We can blend them using one of these blend modes, but it's not going to keep their designs separate and distinct. We're going to have to cut these out so that we have areas of alpha around them. And to do that, we need to do them as color, because it's going to bring in that 4th float that it needs. So each one of these, I'm going to add a gradient map, and I'm going to leave it exactly as it is. But what it's going to do is it's going to convert them to color. And if I come into my image 1 here, I'm still getting black in the areas where I want to be able to show this other stuff through. But what I can do with a color blend that I can't do with a black and white blend is take advantage of that extra alpha channel. To do that, I'm going to make I'm going to make 3 more duplicates of this. Well, I'm not going to do it that way. We're going to make a duplicate of each one. So I'm going to make a duplicate of this one, and then I'll make a duplicate of this one. and they correspond exactly to what's happening with these images. And I'm going to replace those images here with white. And the exact same thing that's happening up here to images number 1, number 2, and number 3 is going to have a corresponding mask made by this second transform node. And then you hook them up to the corresponding image in here. And now, if we come back into our input parameters and start adjusting our image, we have the checkers that we need that show us that this is now see-through, and the image underneath it will show up. And we blend image number 1 over image number 2 over image number 3. But in the end, we're going to want it as a grayscale. So once we've done everything that we've wanted to do to it, we're just going to convert it right back to a grayscale. And let's create an output node. I'll set it as any. Yeah, I think any. There we go. Let's take a look at how this works. So image number 1, I have set, let's set it to horizontal tiling. And we'll make it smaller. You know what? I'm going to set it. Let's try that again. So we'll make this top one smaller. And that's showing image number 2 now underneath. We'll give it some horizontal tiling. And let's move down to image number 2. We can make it smaller. We can set it to vertical tiling. And image number 3, we can do the same thing. It's kind of nice with a border like that, or we can pan it. But our little thing works now. And we now have this nice little engine that will take 3 images and do stuff to them. And to finish it off, just like we did with the carving one, we're going to create some image inputs. And they're all going to be grayscale. We'll call it a mask. Oh, isn't that nice? All we need to do is change the labels. And then we'll replace these guys with our image inputs. And that's our little carving layout machine done. So we have this, and we have this, and all we really need to do is rebuild this super simple little graph that we have here.